class, welcome to our integral class, and for today's lecture we're going to be looking at sigma notation. So we said in finding areas there are several sums that we normally encounter. So we say in finding areas and evaluating integrals we often encounter sums that are of many terms. So one easier way of expressing those sums that have many terms is to bring in the sigma notation. So the word sigma is a kind of Greek letter, and it is also like a letter that is similar to our capital letter S, right? So this is the sigma sign, and it is corresponding to our letter S, and it is called sigma notation. Now let's look at the definition of sigma notation. We say if A sub m, comma, A sub m plus 1, A sub m plus 2, A sub m plus 3, right? Between here now, all of those expressions are found right between here. A sub m plus 4 and so forth, all the way to A sub n. Now, when they are all real numbers and the letter m and n are integers, we know that integers are both the negative and the positive numbers, such that the integer m must be less than the integer n. Then we can say the summation, so the sigma sign that we have here with this thing before it is read as the summation of. So you read the function first. So you say the summation of a function. So the function here now is A sub r, as r leaves from m all the way to n. So that's how it is read. So it is this r now we're going to replace with m plus 1, m plus 2, m plus 3, and so forth to reach to n, the last expression, which is called the upper bound. So this is the lower bound, m, and this is the upper bound, n. This r is called the index of summation, and I will explain that further. This is the summa. I will also explain that further. So we replace r now in this. So the first time we're going to say let r equals to m. We put m. The second time, since it is being increased, so we say let r now equals to m. This time we add 1 to m. The next time we add 2, just like that, until we reach to the last expression, which is n. So if we want to express this a sub r in a kind of functional notation, like we said, with functional notation, we have the above definition to be the summation of f of r as r leaves from m all the way down to n, right? So you're replacing this r now with m, the next one with m plus 1, m plus 2, m plus 3, all the way till you reach to n. It's just like r was equal to 1 and then n now to maybe 5, for example. So the first one will be r is 1, the next one r will be 2, right? So how did we arrive at this 2? We said 1 plus 1. If r is 3, how do we arrive at this 3? We start with 1, then we say plus 2, just like that, until we reach to 5. So we said the symbol, this one now, indicates a summation in which the letter r is called the index of summation, like I said. And also, the letter r can be replaced with any other letters in the English alphabet. It does not only have to be r. So normally we call it a dummy variable, because dummy variables are variables that can be replaced with other variables. So again, like we said from the beginning, m is called the lower bound or the lower limit. N is called the upper bound or the upper limit. So if you look at this entire sigma notation, which we have like this, So this now is the function. R leads from M to N. So this is called the upper bound or the upper limit. This is called the summa. This is called the lower bound or the lower limit. And this is called the index of summation. And then this one now is the sigma sign. So if we put all together now, we call it the sigma notation. So we're going to look at a few examples on how to find the sum. So let's look at a few examples now. It is very easy to find the sum using sigma notation. It's very, very easy. So let's look at the first example. The first example says the summation of R as R leads from 1 to 3. So this is how we go about finding the sum of R as R leads from 1 to 3. So the first one is when R is equal to 1, right? Remember now when R is moving from 1 to 3 means 1, 2, just look at the number line. 1, 2, 3, right? So these are the numbers you're going to replace with the variable within the summa. And there's the summa. So the variable in the summa is R, which is the index of summation. So now we're going to replace R with 1. So we say R is 1. Plus, the next time we're going to replace R with 2. Plus, the next time we're going to replace R with 3. So therefore, we have this to be 1 plus 2 is 3. 3 plus 3 is 6. So this whole thing is just equals to 6. So that's how we find the sum. It's very, very easy to find the sum using the sigma notation. Next question says, we must find the sum for 2k as k leads from -2 to +1. So when it is leaving from -2, the next one you have is what? -1. From there you go to 0. From there you go to 1. From there you go to +2. So since it leaves from -2 to +1, so you must replace k with each of these numbers. So the first one is -2. So we say let k be -2. Now you don't write this summation any longer, this sigma sign any longer, because you are already finding the sum. So we have 2 times -2 plus, next time we replace k now with -1, 2 times -1 plus, the next time we replace k with 0. So let's erase this one. We replace k with 0, so it's 2 times 0. The next time we replace k with 1 plus 2 times 1. We stop because it leads from -2 to 1. So therefore you have 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is just 0. And then 2 times 1 is 2. So -2 plus 2, they all go out. So our answer is just -4. -4 is the sum. So we quickly look at the next one. We have question 3 that says the summation of 1 over k as k leads from 1 to 5. So again, we find a sum. Now in some cases, they will just ask you to expand. If you are just asked to expand, it means this is the expansion. It means this is the expansion. If you are asked to expand and find the sum, or to just find the sum, it means you must add all of them after you have expanded. So the example says that we must find the sum. So this one now we have 1 over k. So we start with 1. 1 plus 1 over k again. This time we move to the next number. From 1 we go to 2, 3, 4, and 5. So these numbers are the numbers we're using to replace k in the summa. So we put 2 right here, plus, next one we put 3, 1 over 3, plus 4, 1 over 4, and then the last one is 1 over 5, plus 1 over 5. So now, to find the sum now, we must be able to find the least common denominator for all of these numbers, right? So, what can be the least common denominator for all of these numbers? Now let's look there. We have 2, we have 3, we have 4, we have 5. So we list the multiples first, and we check among those multiples for that number that is appearing in all of them. So to list the multiple, you start with the number itself, 5. So we start with the number itself, 4, 3, and 2, right? So the next one, we move to 10. We move to 15. We keep adding this number to the result that we get. So let's add some numbers up to get at least close to this 15. So we add 4 to this is 8. We add 4 to this is 12. We add 4 to this is 16. Let's do that for this 3. We add 3 to 3 is 6. We add 3 to 6 is 9. 3 to 9 is 12. 3 to 12 is 15, and so on. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, and so forth. So we add 1 to this is 20. We add another 5 to this now is 25. Another 1 to this one is 30, right? Another 1 to this is 35. Now, you will notice that you will have a kind of long step in finding your least common denominator. One of the easier ways to do it is to just find the product of each of these numbers. All of these numbers, you find a product. So you say 2 times 6, 2 times 3 is 6, 6 times 4 is 24. Then you say 24 times 5. 5 times 4 is 20, 0 and 2. 5 times 2 is 10, plus 2, 12. So it's 120. So now you have found your LCD. If these were just smaller numbers and you can easily find among these numbers, you can use this method. So we now find our LCD, which is 120. So therefore we continue. We have the summation of 1 over k as k leaves from 1 to 5 is equal now to our LCD now is 120. So now 1 into 120 is just 120. 120 times 1 is 120. Plus 2 goes into 120 means 120 divided by 2 is just equal to 60. 60 times 1 is the same as 60. Plus 3 into 120 meaning 3 divided by 120 divided by 3 is just equal to 4, right? It's 4. So 4 times, let's say 40. 40 times 1 is the same as 40. Plus 4 now into 120 is 30 times. 30 times 1 is 30. Okay, so 5 now into 120 is 24 times. Because like 5 into 12, it goes there 2 times. Remember 2, you add 2 on the 0 now is 20. So 5 into 20 goes there 4 times. So it's 24. So now we have 120 plus 60. Now you look at 60 plus this one is 100. This is 120 plus 100. And then 30 plus 24 now is 54. So this whole thing now is just 4, 7, and 2. 274. So we have 274 all over 120. Now we can further reduce this, meaning 2 into 120, it goes there 60 times. And then 2 into this one now, into this entire thing, 2 into itself 1 times, 2 into 7, 3 times with a 1. So 2 now into 14, because the one you added to this is 14, 2 into 14 is 7 times. So it's 137.